This experiment just pops a balloon. And normally when a balloon would pop, you'd hear the whole room just kind of expand, right?
Yeah.
Pretty loud.
Yeah, pretty loud.
But in this room, there's none of that. So you're going to hear it as a very sharp sound that just disappears completely.
Cool.
Welcome to the anechoic chamber. Watch your step.
Whoa. Wow, it is already super quiet in here.
And it's going to get even more quiet when we close the door.
Cool.
How's that?
It did get a lot more quiet. Yeah. Welcome to Science Quickly. I'm Rachel Feltman, and today I'm here with Seth Cluett at Nokia Bell Labs. And you may notice if you're listening to this or if you're watching it that there's some interesting stuff going on with the sound. Seth, would you tell us more about why that is?
Yeah, so we're in the historic anechoic chamber at Bell Labs. It is a room that absorbs 99.999% of sound wave propagation and eliminates sound from the outside almost entirely. It is anechoic, meaning it lacks echo. So an anechoic chamber is intended to absorb as close to 100% of incidental reflection as you can possibly do. This room, as you kind of look around, is a 30 by 30 cube with a wire mesh a third up from the floor. You might ask yourself, like, why is it a third up from the floor, not in the center? And the answer is that you want the experiment to happen as close to the middle as possible, because the one place where it's scientifically feasible to measure sound exactly is in the center of the cube, because the distance to the walls and the reflections are equal in that case. The building is a shell that has 2-foot thick walls and an air gap, and then another wall. And that air gap separates the sound waves from the outside. And then inside the room, there are these 4-foot wedge panels in groups of 3 in an offset kind of orthogonal pattern, a grid pattern. They capture the sound waves before they're able to reflect back. So they come to a kind of inverted point in the inside of the wall, and when sound gets into that point, it kind of bounces back and forth on the diagonal, and by the time it gets to the outside of the wedge, there's no more sound energy left to reflect.
So when you're in this totally quiet space, what kinds of things can you feel and perceive in your body?
I think most people feel a kind of pressure against their ears first. It sort of feels like the air is heavy or thick. Then you start to notice a kind of low pulse and realize that's your heart beating, and you can hear it in the air in addition to through your body. And for most people, you can even hear a high pitch and you think, oh, I have tinnitus or there's something wrong with my hearing. You're actually hearing your nervous system, bone conduction through your skull. And it's quiet enough that for the first time, you can hear a part of your body that's been along with you for the whole time you've been alive.
That's very cool.
Sorry, what?
I was just like, fuck, I can hear that.
You're just hearing
I
the
actually.
system? Okay, no worries.
So I'm glad we
Sorry,
got that.
carry on.
I'm
I'm so sorry.
That was really cool.
Yeah, now I'm really distracted because I can't stop noticing it.
Listening to your nervous.
And so that actually, it's starting to go away for you now.
Right.
Because that's part of the fight or flight response, because you're hearing it through the hypersensitive part of your stereocilia on your basilar membrane that are like, wake up! Are there tigers? Right? Like.
Could you show us some demonstrations to maybe help our listeners and viewers understand like how unique this space is? You've also let us borrow a very fancy mic so that we can present 360 stereo audio so that our listeners and viewers can, experience being in the space as closely as we can approximate.
Yeah, absolutely. It's subtle, and I hope that your viewers are wearing headphones.
So how does this demonstration work?
Okay, so in order to demonstrate how much of the sound the room absorbs, I'm going to sing a sinusoid, a pure tone, straight ahead. You're going to hear that as the loudest, most direct sound. I am not going to change the volume of my sound at all, but I'm going to turn around in a circle. And so as I turn, you're going to hear the room absorbing more and more of my sound.
Okay.
Okay. Sorry, granola bar.
Nice. That is wild.
Yeah.
So how does this one work?
Okay, so one of the kind of miraculous things about an anechoic chamber is it allows you to hear something that you can't hear outside of the chamber. And that's that for every doubling of distance a sound source has to the listener, there's a cutting in half of the volume. And so I'm going to speak to you at this level. And then I'm going to double the distance, and you're going to hear the same timbre, the same quality, the same emotional content as I'm talking now, but just at half the volume. And then I'll double it again, and you'll hear even more of a fall off in the volume.
Cool.
Okay, so this is me talking at the normal volume, and I'm going to move back double. And this is me talking at that same volume. It's just half as loud for you. And this is me talking at the same volume, and it's half as loud again.
Wow. Yeah. It's very weird to have it be the level of a whisper, but not sound like one.
Right.
So we're obviously recording a podcast and a video right now. What kinds of technologies were created here that make this kind of multimedia possible?
It's kind of overwhelming, honestly. The bit of digital binary was invented here, and as an extension, Claude Shannon and John Pierce invented pulse code modulation, which is the way we record sound digitally. The charged coupled device, the CCD that captures video, was invented here. The transistor, the list goes on and on. Even the Jazz Singer, the first sound film, the technology for that was developed by Western Electric Bell Labs, making it possible for us to synchronize sound and image for film.
And what kind of experiments have happened in this chamber since then?
A kind of remarkable amount of things that touch our individual lives. Like we think about the touch tone phone, the bop, beep, bop, 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 bop. The individual tones and their tuning are optimized for memorizing phone numbers. And the acoustic research paired with psychology, or what we call psychoacoustics, was done in this room in order to help people figure out how to memorize the most phone numbers as the nation's telephone grid got larger and larger. And it wasn't just Bronson 257. Right. So in addition to that, fundamental research into synthesizing the sound of the human voice, right? We talk about microphone research and loudspeaker research, but that's not the entirety of it. Behind that is signal processing research that's about how do you optimize the signal to go long distance. And at first that was how do you optimize a signal to go over a long run of copper wire, right? Reusing the telegraph system. And now in wireless, how do you encode a signal to minimize the amount of data taken up and maximize the quality of the voice? We think of science as being hard measurements and facts. And one of the things that's remarkable about Bell Labs in the 60s and 70s was human factors research. Like, how does it feel to use technology? And one of the convincing things in telephony was, how do you make sure, as you're reducing the signal, that you're not throwing away emotion, that you're not throwing away recognition, that you can still recognize the person that you love on the other end of the line. And I think one of the things that this room actually shows us, and the audio for this podcast will actually reveal a little, is that the digital silence in cell phones is actually really dehumanizing. That like without the space around the signal, you lack context for the other person. And you're like, are you there? Are you there? And because the absolute digital silence makes you feel quite alone.
Yeah, that's really interesting. So I know that you are an artist in residence here. How did you get involved with the lab?
Sure. So I've been here since 2017, so this is my 8th year in the artist in residence role. When I first arrived, I came in as part of a reboot of the Historical Experiments in Art and Technology program, which was founded in the 1960s. Then in 2014, there was a reboot of like the role of artistic research at Bell Labs in one form or another. And because so many media technologies intersect with scientific research, the idea was, let's bring in artists, left brain thinkers, to ask kind of divergent questions in a linear engineering space. And so when I first came, I was very active, moving lab to lab, asking questions of engineers and technical staff of what their research was and getting them to enter a dialogue to try to see what sort of divergent left brain thinking might contribute to a kind of linear engineering research and development space.
Awesome. So what kind of stuff have you been working on?
So I've been really interested in what I'm calling the last 10%. In psychoacoustic research, so much of the things that we know about the sound world were developed either for telephony or for the military. So can we get a signal efficiently across a line, or can we triangulate something in space, so sonar and radar and those sorts of things? In virtual reality and in artificial intelligence, now the question is, how do we pass the kind of uncanny valley of like, this is almost real, but it's not right? What I'm interested in is, what are the aspects of sound that are kind of soft factors, that are the human things that make us feel like we're situated, that make us understand the context? The auditory equivalent of depth perception was something that was never, looked at seriously in the initial sort of foundations research. And so I've been doing experiments around loudspeaker array design and microphone array design to try to think about what is hiding in the signal that our brain is processing that might not appear in the physical acoustics, that give us a real sense of belonging, like a sense of space, like I am in this space and it's me and my body, not just my mind.
And I know that in addition to the kind of experiments that have been done here to contribute to technological advancements, there's also been just sort of a lot of interesting art projects that have happened here. What are some of the stranger, more interesting things that have been done in this room?
Sure. I mean, a lot of people don't realize that the first time a computer sang was at Bell Labs, right? So at the end of 2001: A Space Odyssey, when Hal is singing Is Dying, and he sings Daisy.
Daisy, give me your answer.
That was heard by Arthur C. Clarke when he did a tour of Bell Labs, and then was incorporated into the movie because it was the first time a computer sang. So the idea of giving the computer some human character came from trying to figure out speech synthesis problems. Because if we could understand the nature of the way that speech was synthesized digitally, we could initiate the revolution of automated telephone answering, right? Or the synthesized voices that AI responds with. All of that foundational research was done in spaces like this, and it was done first by asking a computer to sing.
Very cool. And I know somebody brought a grand piano in here. We learned that as reassurance that the wire floor was not going to give out underneath us. Yeah. What was that about? Because, I feel like acoustically, this is objectively not great to make music in.
I wasn't around for the grand piano experiments, but at the start of my residency, we had an artist in residence partner, collaborator, the International Contemporary Ensemble, and we brought a 12-person chamber orchestra into this room and a 4-person orchestra, or ensemble, into the adjacent room. And we were able to transmit the anechoic sounds, the sounds without reverberation, to an adjacent space and apply a new space in real time. So we could dial in Carnegie Hall, or dial in an outdoor forest, or dial in, the best shower you've ever sung in, right? And so that ability to act on signals that haven't yet been touched by space helps us understand how to process the signals that give us a sense of where sound is coming from.
I feel like a lot of the sort of mainstream conversation about anechoic chambers is that it feels really freaky to be in them. And you hear some probably hyperbolic stories about a sense of panic. Why is it that it feels so strange for us to be in here? And I'm also curious, how do you feel about being in the space?
I love being in it.
Yeah.
I think in like we talk about the attention economy and that like we're all on our phones and we've got earbuds in all the time and we sleep to white noise and we sleep to music. One of the remarkable things about this room and the people who are doing the recording around us right now are beginning to experience it. When you're in here for 20 minutes, your fight or flight response that's active all the time, like if you step your foot off of a curb and you hear a bicycle messenger ding their bell and you pull your foot back automatically, that automatic retraction of your foot is happening because there's a jumper between your auditory cortex and the part of your brain that's responsible for your physical motion, and it retracts your foot without you having to tell your foot to retract. The fact that it does that is because the brain is capable of that precognitive response because we're in a heightened mode of attention with our ears, and we ignore 85% of the sound of the world all the time. Otherwise, we'd be, subject to the same kind of sensory processing disorders that are so common, right? When you're in here for 20 minutes, the little hair cells on your basilar membrane inside of your ear relax, and it gets 10% quieter. And I think there's that moment where you're like, where's the stimulus? Where's the stimulus? And that feels panicking in the same way as like, why hasn't anybody responded to my text? And I think if you change your perception to a longer arc of where is my body right now, you start to realize like my heart rate's lowered, lymphatic production slowed down, my breathing is slower, and you can center into a kind of space that's really sort of unheard of in the 21st century. I hold two roles. I'm the artist in residence at Nokia Bell Labs, and I'm the director of the Historic Computer Music Center at Columbia University. And in both of those places, I'm interested in the same thing, what I'm calling sort of sensory computing or speculative acoustics, like this idea that it's important for computers to not just process text and language, but for computers to understand the world around them with the same level of resolution that we do, right? If we want to expect intelligence out of machines, we don't just know things from memorizing things out of books and off the internet. We know things by walking around the world. And so for me, the intersection between engineering and the real world is this fascinating place where the resolution gets clearer and clearer the more you kind of attune the rest of the senses to catch up to our ability to process text, right, and vision, which has led the charge for so many years. I think the solution to so many of the questions of like what the next 100 years is going to feel like in terms of the way we interact with computers are going to come down to how embodied we feel, and then as an extension, how safe we feel around the computer.
So I understand that this facility is going to be closing down in the next 2 years. What do you think you're going to take away from having worked in this space for as long as you have?
I'm tempted to say something sort of profound about my own practice and its effect on my practice, which has been sort of immeasurable, right? Like having the ability to record an absolutely dry audio for someone who composes electronic music is like unmeasurably positive, right? But for me, the real impact has been watching and leading dozens of school groups through, from elementary school through college, students from Harvard and students from Rutgers, students from Ramapo College and students from Carnegie Mellon, coming in and for the first time experiencing something absolutely new, right? Yeah. Like that sense of awe at the kind of sublime, like the reason we sit in front of mountains and stare at the ocean, this is just the same, but for the absence of stimulus. And I think for a lot of people, it's a real revelation that maybe technology writes on us a little bit too much, and it's time to kind of shake the Etch-a-Sketch gray and start writing over again.
Well, thank you so much for taking the time to chat with us and for, showing us around, telling us how this room works. It's been really cool.
Yeah, it's my pleasure. Thank you. Thank you for having me.